So problem 1-9, we consider an annuity where you pay 79.04 every year in interest on loan. The total loan is 1,000 and the interest is 4%. And the first payment is now. How many years will it take until the loan is paid back? So let's draw up the payment stream and also write down what the unknown thing is here that we're looking for. So it says consider an annuity where you pay 79.04 every year. So we consider a payment stream where every year we pay 79.04 and we do so until time n. Let's see, the interest is 4% and the first payment is now, so we know that at time 0 we pay the first 79.04 and then at time 1 we pay the next, and so on and so on. How many years will it take until the loan is paid back? Well, essentially we can actually see that what we have here is an annuity due. So what we have is an annuity due, and what we're asked is what is n? How many years n does this annuity due have to last before the loan is paid back? So what is n before the 1,000 is paid back? So let us recall what fairness states. Fairness tells us that the time 0 value of all benefits should be equal to the time 0 value of all contributions. So if we think of the 1,000 as our benefit, and we receive this at time 0, right? So 1,000 is our benefit at time 0. Then our contributions are given as these 79.04 each year for an unknown number of years. So our contributions value at time 0, including the contribution at time 0, is given by 79.04 multiplied by the present value of an annuity due at time 0. And that value is given by this a dot dot n. Alternatively, we could also just use the common sense first before we use the symbol. We could say, well, first we have this 79.04, and then we have the next 79.04 that have been discounted 1 period, and then the next that have been discounted 2 periods, and so on until the last one that was discounted n minus 1 periods. Okay, so this is the equation that we have that describes fairness. And now we have to find n. So find n. How do we do that? Well, let's take a look at this. If we look inside the book, then the initial present value of an annuity due that lasts in periods is given by the fraction 1 minus v to the nth divided by 1 minus v. And that's good because we can see n in this expression, so the only thing we need to do is to isolate n. In the expression 1,000 equals 79.04 multiplied by 1 minus v to the n divided by 1 minus v. Now, this means that, so this holds, so this holds true. So hence, we have that 1 minus v to the n is equal to 1,000 divided by 79.04 multiplied by 1 minus v. And also, we can then get that by adding v to the nth on both sides and subtracting this on both sides, we have that v to the nth is equal to 1 minus the right-hand side above, as such. Now, in order to find n, I just take the log on both sides, and recall the rule that log of something to the nth power is equal to n multiplied with the log of that something. So we get, by isolating n, we take log on both sides, and then we get n log v on this side, and log of this on this side, and then we just divide log v over. So we get that n is equal to the log of 1 minus 1000 divided by 79.04 multiplied by 1 minus v divided by log of v. And that, if we put that into the calculator, we get 16.99 or something like that. So that's approximately 17. So how many years will it take until the loan is paid back? Approximately 17 years, then the loan is paid back. And the loan is paid back in 17 payments, from where the first payment is at time 0, and then the next at time 1 and 2, and so on, until year 16, the beginning of year 16. So we have 17 payments, each of size approximately 80.